Okay, so what we're briefly going to review is included angle and included side. So let us remember that an included angle of a triangle is an angle formed by two given sides. So basically, if I have one side and another side that touch, what they form right here is an included angle. So an included angle is an angle which is created by two sides. And so this is the example that you see here. You see AC and CB. Those two sides are put together to create that included angle. All triangles have three included angles because all the sides meet up at three angles. So like this side and this side, they create this congruent included angle. This side and this side creates this included angle. So the included angle is basically just that side that's formed by two sides. That's basically what an included angle is. An included side, on the other hand, is going to be whenever you have two angles. So you have this angle and this angle. The angle that's in between them, so like this side, the side that's in between them, sorry. This side right here would be your included side. So basically, the side that is part of those two angles. Okay. So that is included side. And all triangles have three included sides. So if I have this angle and this angle, the included side will be this one. If I have this angle and this angle, the included side will be this one. So basically the side that they have in common, those two angles have in common. Okay, so that is included side and included angle. So from that, what we are able to use is we're able to use these different theorems. We're going to look at 3 today, which help us to prove that triangles are congruent. So first, we're going to look at the side angle side congruence theorem, also known as the SAS theorem. And we're going to see how that will help us remember this theorem. It states if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then those two triangles are congruent. So basically, we can use this theorem to prove that these two triangles are congruent. So basically, it's saying if two sides, so these two sides will be congruent, and these two sides are congruent. If two sides are congruent and their included angles, so the angle that they create when they connect, are congruent to the two sides in an included angle of another triangle, then those two triangles are congruent. That's what this is saying. An easy way to remember side angle side is basically it's saying if you have two sides which are congruent, so side angle side, you can remember that this needs to be an included angle because it's in the center. Whenever you see an A in the center, you want to think included angle. So it's going to be an included angle. An angle which is created in between two sides, right? That's my included angle. An angle which is created between two sides. That is what an included angle is. So if we know that two sides and the included angle of those two sides are congruent to another triangle with two sides and an included angle that are congruent, then what we know is that these two triangles will be congruent to each other. Okay? Questions about the side angle side theorem? So, for example, can we use the side angle side theorem to prove these two triangles are congruent? Well, remember that side angle side, and I can go ahead and move this over. My side angle side theorem told me that I have to have two congruent sides that also have a congruent angle, included angle. So can I use the side angle side congruence theorem to prove that these two triangles are congruent? Well, what I notice is they share two sides. This side is congruent to this side. This side is congruent to this side. That's what those symbols mean. And now I want to see, is it that angle that I see there an included angle? Well, yes, it is an included angle because two sides form this angle right here. And so that would be my included angle. these two sides form this angle right here, and so that is my included angle. So basically what this is telling me is that I have two sides which are congruent to each other and two included angles which are congruent to each other, and so therefore those two triangles are congruent to each other. So therefore I can use the side angle side congruence theorem to prove that these two triangles are congruent. But what about this example? Can I use the side angle side theorem to prove that these two triangles are congruent? Well, I do notice that I have one side which is congruent to another side, this side which is congruent to this side, and I do have an angle which is congruent to this other angle. But what I notice is those two sides that were congruent to each other, they form this angle right here, not that green angle. And these two sides form this angle right here, not this other angle. And so therefore, that green angle is not the included angle. And so therefore, I cannot use the side angle side theorem to prove that those two triangles are congruent. Because if I were to prove that those two triangles are congruent, then what I would want to see is that this angle is congruent to this angle, because that's the included angle. In the side angle side congruence theorem, you only want to use the included angle. So because that's not an included angle, we couldn't prove that those two are congruent using the side angle side theorem. Okay, questions about this? Okay. So yes, we reviewed included side already. Okay, so now we're going to look at the angle side angle theorem. So we can remember this by A, S, A. And basically what this theorem is going to tell me is if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then those two triangles are congruent. So it tells me if I have two angles which are congruent to each other, and remember whatever's in the center is going to be my included. So this is going to be my included side, my side in between those two angles. If my two angles and my included side are congruent to the two angles in the included side of the other triangle, then those two triangles are going to be congruent. So I'll see that here. This angle is congruent to this angle. This angle is congruent to this angle. Now let's look for the included side. This is the included side. Are the sides congruent to each other? Well, yes, this symbol tells me that they are. And so because those two angles are congruent to each other and the included side are congruent to each other, we can use the angle side angle theorem to prove that these two triangles are congruent. So again, you want two angles to be congruent to each other, and then you want to make sure that you have the included side also being congruent to each other. And you want to make sure it's the included side, not just any other random side. It needs to be the included side, so the side that's in between those two angles. And that gives us the angle side angle theorem. Okay, so here's an example. Can we use the angle side angle theorem to prove these congruent? Remember, angle side angle says that I need two congruent angles and then the included side in between those angles to be congruent. So this angle is congruent to this angle. This angle is congruent to this angle. And now I want to look for that included side. This would be the included side. This would be the included side. Am I told that those two are congruent to each other? Yes, I am, because I have that symbol right there. And so therefore I can use the angle side angle theorem to prove that these two triangles are congruent. Okay, how about this example? Can I prove that these two triangles are congruent to each other? Well, I have one angle that's congruent to another angle. This angle, which is congruent to this angle. Let's look for their included side. There's their included side. But I'm not told anything about those two sides. I don't see a symbol there that looks like this, which tells me those two are congruent. And so because I'm actually not given any information about any of the sides, then I know that I cannot use the angle side angle theorem to prove that these two triangles are congruent. Because first of all, I don't have the included angle being told to me is congruent to the other included side, but I also don't know any information about any of the sides. And so I wouldn't use that theorem to prove these two congruent. Okay, questions? Okay, last one. Angle angle side theorem. So you can use the angle side theorem to also prove that these two triangles are congruent. Angle side. So we want to prove that two angles are congruent. But now I have a side, but it's not in the center, right? The side's on the outside, and so this is not going to be an included side. This is just going to be any side. So basically what this theorem is going to tell me is if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the two triangles are congruent. So in this one, I don't need an included side and I don't need an included angle. All I need to prove is that two angles are congruent and an additional side. Okay, so this angle and this angle are congruent. This angle and this angle are congruent. And then I just have this random side over here, which is congruent to that random side. And so because I have two angles which are congruent to each other and a side which are congruent to each other, then I know that those two angles will be congruent to each other. So the difference here is that I can use any side, where in my other one, I needed to use the included side. My included side had to be congruent. In this one, it can be any side, any other side besides your included side. Okay. So here are the different theorems we looked at. Remember that we remember side, angle, side. If two triangles are going to be proven congruent using the side, angle, side theorem, I want one side to be congruent, the included angle to be congruent, and then my additional side to be congruent. So I want my two sides which create that included angle to be congruent and that included angle to be congruent. That's what I could use to prove by the side, angle, side theorem that my two triangles are congruent. So this is the example. This side is congruent to this side. This side is congruent to this side. And what do I know? My included sides are also congruent. Okay, and remember, you can remember that you need the included side just by SAS because that A is in the middle. That means it's going to be the included angle. Okay, so I need to prove that two sides and the included angle are congruent to each other. Then we have ASA. It basically tells me I need one angle, my included side, and another angle. If I can prove that all these three things are congruent to another triangle, well, then I can use the ASA theorem to prove that they're congruent. So this angle is congruent to this angle congruent to this angle. Let's see if that included side is congruent. Well, yes, I have that symbol right there. And so therefore I can use the ASA theorem to prove that those two triangles are congruent. Remember, because your S is in the middle, you know that you're looking for the included side. Okay, if you can prove all these three things, then you can use that theorem to prove that those two triangles are congruent. Lastly, the AAS. So you're just looking for an angle, and a side. Any side you want to be congruent. If you can prove that two angles are congruent plus a non-included side to any other side, then you can prove that those two triangles are congruent. So here's the example. This angle is congruent to this angle. This angle is congruent to this angle. Let's look for that included side. And so I want anything other than my included, any other side other than my included side to be congruent. And I'm told that this one's congruent. It's not my included side, and so I can use the AAS theorem to prove that this is congruent. So basically what you can do is you can prove two triangles congruent using any one of these theorems, depending on what type of triangles or what type of diagrams you have. Okay, but these are the conditions that you want to meet in order to use that theorem. Okay, remember, this one needs the included angle, this one needs the included side, and this one you can basically have any side. Yes, questions? Okay, we will go over example problems tomorrow, but if there's no other questions, you guys may log off. Bye, guys. Mhm.